So as part of this project, we changed a lot of the equipment. So you can see the old Wells turbine down here was removed, and we put on this new turbine here, which is an impulse air turbine. Slightly less proven in terms of actual offshore testing or wave energy deployment than the Wells turbine. So that was one of the goals of this project, to look at this new component, and particularly with respect to the movable guide vanes. These are the rotor blades of the actual turbine, and then on either side of the runner, there are two sets of guide vanes which move between two positions, depending on the direction of the airflow. So when the airflow is going in one direction, out of the chamber to atmosphere, the guide vanes will move to one position, and then when the air is reversing, the guide vanes will move to another position. And these two angular positions were determined from laboratory tests in the institute in Portugal, where they were designed as the optimal positions for power takeoff. And these guide vane system then was controlled by a hydraulic actuator, which is installed here underneath the piping. And within this device then, if you see this hatch area down here underneath, as part of this flotation area, there is a control room. And in that control room we install all the electrical equipment and the hydraulic power pack for driving this actuator. So this now is down in the actual control room, below the deck, where the main power equipment was installed, the control equipment, and I'm just showing here some of the actual power equipment. A rather unique thing about this installation was that we installed on the device a three-phase island grid. In previous work that we had done with this company, we had just used a DC generator with dump loads for getting rid of the energy that was generated, because there is no grid connection here. But in this case, we felt that it would be better to actually install a three-phase grid on board, because it would give a more realistic testing situation, and we could look at the actual power that would be exported to an AC grid in a full-scale situation. So I'm not sure there's many electrical engineers here, but if you are, you can follow this diagram here, where we had a three-phase induction generator, which generated at our normal three-phase voltage in Ireland, 400 volts, a back-to-back frequency converter with a three-phase island grid here now on the board. That island grid was created by these inverters, which are these Sunny Island inverters here made by a company called SMA from Germany. They're derived from a 24-volt battery system. So they create that grid, they create the synchronization for the grid, and they also control the charging of the batteries on board. There's also required to be a backup diesel generator, because there are many times when for several days there will be no waves and it will be very calm. In that situation, we need to maintain power to the onboard systems, the communication systems, the control systems, the DC, the bilge pumps. All of these systems need to be kept operational even when there are no waves. And so because we had no grid connection, we had to supply this backup diesel generator on board in order to keep the system operational. So when the system is generating power then, the power flow comes from the generator, primarily charges the batteries. If the batteries are fully charged, there's a dump load controller which changes the frequency of the grid, and in so doing controls the amount of loading resistance that's connected to the system. Gets rid of the excess power. Just looking at some of the sensors on board, we try to put as many sensors as possible into the system so that we can understand and get good research data. So if we look at the actual duct, turbine duct, there were several lines of pressure transducers all along the duct, both for measuring the pressure drop across the turbine and along the duct, and also so that we can try to determine the airflow in the duct. There's a centre of gravity, a motion transducer near the centre of gravity. There was a weather station on the top. The system is moored. There's 3-point moorings, and on each mooring point we put a mooring load cell to measure the mooring forces. There's air pressure sensors in the air chamber, and there's underwater pressure sensors in the actual oscillator water column. And you can't see it here, but there was also a water level sensor, and also other sensors such as vibration, current, voltage, speed, etc. One of the moorings themselves were instrumented as well, with an accelerometer for measuring motions, and also a load cell for measuring the actual loads at the mooring itself. An important part of the system was the communication system, because we needed to be able to remotely control and access the data in real time. So we had an onshore broadband internet router that was connected by a radio link. We also had a backup 3G system in case the main radio link failed. And this allowed us to remotely access all of the control computer on board, and also to access the various webcams that were on the system. And it enabled us to run different tests at different settings, depending on the wake conditions. These are just some pictures of the deployment. Again, this quite similar to the pictures Tony showed of the previous deployment, the loading onto the low loader and transport down to the docks, and then lowering to. This is showing the device being towed out to sea and moored on station. Get this to work. This is just some of the webcam shots of the device while it was in operation recently. It's not easy to see the motion, because the camera's on. But if you look at the horizon here, you can get some feel for the actual motion of the device. So it was at sea. Our test program was for 3 months, and just this week, while we were here, it was last week actually. It was towed into shore, and this week it is being decommissioned. So it was relatively successful. As you can see, I'll talk you through some of the issues we had with the different components. Thankfully, we had a very windy and stormy May, which is unusual for us, because we were supposed to deploy the system last August, September, but due to delays in the project, we were not able to deploy it until February, March. So we were hoping that the spring would not be too calm, and thankfully May was quite severe weather. So we did manage to get a few storms.